If you were here in Maui last March, we all held our breath. And a lot of you folks followed our feed on Twitter and Facebook and actually told us they thought we had the greatest news source in the world coming out of here. Thank you. How many of you folks follow us on Facebook right now? Are you? Thank you. If you haven't gone on, check out our Facebook page. People love it, and it's very interactive, and we share news with you around the world and what's going on every day. But you know, when the tsunami happened, we all headed for high ground and waited and waited. And then all of a sudden, the ocean receded around Maui. 100 yards, 200 yards, 300 yards. The harbors emptied out. The reefs were exposed. And then the ocean came rumbling right in. You see, what people don't realize about a tsunami, it's not necessarily just a wave, it's energy that runs from the floor of the ocean to the top, and it's moving straight across. And when that wave, when the water recedes, that wave that comes at you can be stories high, and it can inundate. And we saw what happened in Japan, and how literally no one could outrun that tsunami that happened there. Well, now we've got another issue, and that is, as Bill said, those millions of tons of debris in the ocean had to go somewhere. Dr. Jan Hafner is the scientific computer programmer at the International Pacific Research Center, School of Ocean and Earth Science and Technology at the University of Hawaii, Manoa. He earned his degree in meteorology in 1990 from Charles University in Prague. In 1996, he completed his PhD studies at the University of Alabama in Huntsville. And between 96 and 99, he was a postdoctoral fellow at the Cooperative Institute for Research in the Atmosphere at Colorado State University. His work encompassed satellite data processing and analysis, numerical modeling on regional and global scale. I invited Dr. Hafner here tonight because sometimes scientists like Dr. Hafner affect and know many things, but never come out. We don't see them enough. These are the guys and ladies that make a difference. He will be speaking tonight on his groundbreaking work in tracking the Japanese tsunami debris, including a model and observations, a project that he's working on with Dr. Nikolai Maximenko of the International Pacific Research Center at the University of Hawaii as well. Please welcome Dr. Hafner.
Good evening, and thank you the Whale Foundation for this wonderful opportunity for me to present to you some results of our work, and also for the chance to visit this island for 10 years. I've been living and working in Honolulu. I've never been to Maui, so this is my first trip. So I'm looking forward to come more often and talk more about our work. I work with Nikolai Maximenko at the International Pacific Research Center, and we do the work in physical oceanography, so that's our field of expertise. And I would like to acknowledge the contribution by our collaborators, Rick Lumpkin, Luca Centiori, Yi Chao, Doug Wooding, and Hank Carson. And we all know what happened on 11th of March last year. Tsunami struck Japan, and I believe all those images are probably very familiar to all of you, because those are the images that were in the media. And Okay, so this is those images from the tsunami which happened last year in March. And that event created a massive amount of debris. Those numbers range from 5 million to 20 million. Actually, the official figure from the Japanese officials was 25 million tons of debris. Just for comparison, the middle-sized car is about 1 ton. So, and the total number of total amount was about 20 million tons. But it doesn't mean 20 million tons in the ocean. So what happened, all those debris, some of it was deposited on land, something is sinking down, but some portion is still floating. So, and we do not know the percentages. Actually, we did not know until yesterday. Yesterday we had a meeting with Japanese colleagues, and actually they gave us some better numbers. And they estimate that about 5 million tons got into the ocean. And out of those 5 million tons, about 1/3 is still floating. So we are talking about 1 to 2 million tons of debris still floating probably today. Of course, now the question is what is happening with all the debris, and our expertise is in physical oceanography, and we know about surface currents, and that's actually the vehicle, the engine that is driving or is carrying the debris in the ocean. And ocean surface currents were studied for a long time, since '79, by this device which is called drifting buoys. And the drifting buoy actually transmits the signal to the satellite, and based on the information from the buoy, we can make the trajectories. This is the example of one buoy, the trajectory for this period of time, since September 2005 to February 2007, so they can last for quite some time. And just to show you this is the map of distribution of those buoys in one particular day, which happened 7th of March 2011, just before tsunami. And as you can see, the distribution is not very spread out in space. There are some holes, including the Japan. There were no drifting buoys close to Japan when the tsunami struck. So we don't have any tracking buoys in that field of debris. And during our research, even before the tsunami, we realized we can look on the drifting buoys as a marine debris, because actually when they cease to function, they become the marine debris. And this is just for comparison that probably the type of debris that corresponds to our drifting buoys, the movement of the buoys is close to those big chunks of debris. So now we have our buoys, but the problems with buoys is not spatial, and distribution time is not very good, so we need some better tools. And since we do the science and research in satellite data, so we use the satellite data for sea level and for the ocean surface wind, because those are two major components that drive surface ocean currents. And we developed our model, surface currents from diagnostic model. So this is just the representation how all the process works. We got the data from satellites and process it through our model, and we have the global map of surface currents on 1 degree, quarter degree grid, which is about 25 kilometers, and every day starting in August 1999. So that's good. Now the question is, how can we apply it on the problem of tsunami debris? Actually, I will skip it. I will get back to the previous slide. So now the question, when the tsunami happened on 11th of March, immediately there was the question, what's happening with that massive amount of debris, what's